Hey guys, this is going to be a three-part lesson, and we're going to be starting our polynomials unit. And it's going to be a pretty brief unit as we prep for sort of the final major stage of the year. Polynomial is just an algebraic expression with multiple terms. Monomial is one term, binomial is two terms, trinomial three terms, and then polynomial is four and more. And a term is separated with a plus or a minus sign. So we're going to be working with polynomials this week. Now, the first part of this lesson is going to be adding and subtracting polynomials. And this is really straightforward because it's really just using our combining like terms that we've been doing all year. And so let's just go ahead. We're going to share screen. We're just going to do a couple of examples for each of these different sections. And it should hopefully be a pretty quick and easy lesson for each section. So we're going to share screen with our .cam here. So adding and subtracting polynomials. A polynomial, again, is going to be something with multiple terms. So this is a trinomial in parentheses, and this is another trinomial in parentheses. Now, if there were no parentheses, we would simply combine like terms. But these trinomials are in parentheses, and so we need to basically get rid of the parentheses first. Well, we're going to use distributive property, and there's nothing in front of the parenthesis. So it's as if there's a 1 in front to distribute. And then this parenthesis also has a 1 in front to distribute. Well, the beauty of that is anything times 1 is itself. So as we distribute the 1 into the parenthesis, all of the terms that are in there are now free of the parenthesis. Same thing here. If I distribute all three terms, are now free of the parenthesis, and notice they're the exact same because anything times 1 is itself. And now we're simply just going to combine like terms. And remember, like terms have the same variable, same exponent. So the 3x squared partners up with the 4x squared, giving me 7x squared. Remember, the exponent's not going to change. Exponents only change when we're multiplying. 5x and negative 8x will leave me with negative 3x. And negative 7 and negative 11 gives me negative 18. And that would be your answer. That would be simplified. So when we add and subtract polynomials, we simply just free them from the parentheses by distributing a 1 and then combining our like terms. Well, you guys are probably going to realize that you can do a good chunk of this mentally as long as you understand that the terms in the parentheses are going to stay the same. What happens, however, if we have a minus sign separating these two polynomials? So the first one has 4 terms, so that's simply just a polynomial. And the second one has 3 terms. I accidentally wrote an x, but that's 6y squared. And there's a minus sign. Well, again, there's a 1 in front. And in this case, there's a negative 1 in front. Well, for this one, when I distribute the 1, to free everything from the parentheses, I'm going to get 7y to the third minus 8y squared plus y minus 4. The second parenthesis is the key. When you distribute a negative 1, everything in the parenthesis is now going to be the opposite sign. So negative 1 times 6y squared is negative 6y squared. Negative 1 times negative 5y, positive 5y. And negative 1 times 7 is negative 7. And now combine the like terms. 7y to the third doesn't have anything else, so it's just going to be 7y to the third. Negative 8y squared and negative 6y squared is negative 14y squared. Plus 1y and plus 5y is plus 6y. And negative 4 and negative 7 make negative 11. So again, distribute the 1 to free it from the parentheses and then combine like terms. If it's a minus sign, then you're going to distribute a negative 1. So everything's going to be the opposite sign. And again, you're probably going to get to a point where you can do these mentally, and you're not going to have to really show a lot of work once you get comfortable with it. All right, so let's do one example here. This one has 3 sets of parentheses. And so we're going to have the 1 here, a -1 here, and a 1 here. So you're going to distribute those, free everything from the parenthesis, and then combine like terms. So go ahead and pause this for a moment and come up with the answer for this example. All right, so now that we have all got our answers, let's just check it here. We're going to distribute a 1. So that's 3x squared plus 4. In this one, we're going to distribute a -1. So everything's going to be the opposite sign. So it's going to be -8x squared, positive 7x, and -11. And the final parenthesis just has a 1 to send in. So that's going to be 3x minus 13. And now I'll combine like terms. The 3x squared and the -8x squared makes -5x squared. I'm going to go with the 7x and the 3x to get plus 10x. And then 4, -11, and -13 is going to make -20. Now we want to keep it in descending order. So we want to go with the largest exponent in front and then work our way down to the smallest exponent. Okay. So this is, let's stop sharing screen here. This is the first section of our polynomials unit, simply adding and subtracting polynomials. So distribute the 1. If it's a negative, distribute the -1, and then combine like terms. So you can go ahead and pause the video here because this is going to be the end of part 1. All right, here's part 2 of this week's polynomial lessons. And this one is also largely review. Part 2 is going to take a monomial and multiply it by a polynomial. So monomial, 1 term, and you're going to multiply it by a polynomial. It's essentially distributive property. Now, the only thing that's going to get added to this is that we're now going to use some of our exponent rules from the previous unit as we apply it to distributive property. So again, let's take a look at a couple of examples of what this is going to look like. So our first example here just starts with a very basic distributive property problem that we would have done much earlier in the year. And so we're going to distribute here, here, and here. And we're just going to go 8 times 3x squared is 24x squared. 8 times -8x is -64x. And 8 times 11 is plus 88. So again, just take whatever's out in front, distribute it, send it into the parentheses. Now we're going to continue reviewing distributive property because a lot of these things we've already seen earlier in the year. So for this one here, we're going to distribute the 3x squared. We're going to send that into the parentheses. Now this in-between step of work, you don't have to show, but I'm going to show it at least for these examples. So when I multiply, this becomes 3x squared times 4x squared. And then it's 3x squared times -8x. And it is 3x squared times 7. So the 3x squared gets sent in and multiplies. Now we're going to have to remember our exponent rules and how we multiply things with coefficients and the same base. So for this one here, the 3 and the 4 multiply, and that makes 12. And the x squared and the x squared is the same base, so we add the exponents and get x to the 4th power. For the second one here, 3 times -8 is -24. And an x squared and an x will make x to the 3rd power. And then over here, 3 times a 7 is going to make positive 21. And then the x squared is attached because there is nothing else to change the exponent. So again, basic distributive property, just keep in mind some of your exponent rules. So this one here is just going to take the same idea as example number 2, but it's just going to add a little bit more of a layer to it. So we're going to distribute here and it's going to be negative 2xy times 5x squared y, negative 2xy times negative 8xy squared, and then negative 2xy times 11xy. So the negative 2xy is just going to get sent in and multiplied to everything. And you don't have to show that in between step of work, but if it helps, go for it. What I'd like you to do right now is go ahead and pause this and finish this problem and get the answer before it's shown to you. All right, let's take a look at what you got here. This first one is going to be negative 10 x to the third y to the second. So the negative 2 and the 5 makes negative 10. X and x squared makes x to the third. Y and y makes y squared. Okay. The second one, a negative times a negative, is going to be positive 16. And that's going to be x squared y to the third. So now the exponent is larger on the y because of the y squared in this term. And then the final one is going to be negative 22. And xy times xy is going to be x squared y squared. Make sure both the x and the y have their own exponent of 2. Nothing can combine like terms at this point because all of them have slight different variations to their exponents. And as far as descending order is concerned, you're just going to leave it because there's no real way to know for sure which one should be first. All right, one last thing to look at here as far as using this idea of multiplying a monomial times a polynomial. In your IXL section, they're going to ask you to find the area of a rectangle. And if you recall, the area of a rectangle is base times height. Well, in this case, the base is 3x plus 5, and the height is 2x. So the area will equal 3x plus 5 times the height, which is 2x. Well, I'm going to use the distributive property just because it's after the parenthesis. Doesn't change the fact that this is going to get sent in. And so when I do that, the area is going to equal 6x squared plus 10x. And the area of that rectangle then is just going to be an expression with 2 terms. So part 2 of this week's polynomial brief unit is multiplying a monomial and distributing it into parentheses and multiplying it by the polynomial. You can go ahead and pause this here because this is going to be the end of part 2, and then we'll continue with part 3 for this week's lessons. All right, here is part 3 of this week's polynomials section. And this is going to be multiplying a binomial times a binomial. That's 2 terms times 2 terms. Now, when we first see these, a lot of times we make an assumption about what the answer is going to look like. But there's something that's going to go on behind the scenes that's really important to look at. So let's go ahead and share screen here. And I'd like you to look at the first example for our multiplying binomials, x plus 4 in parentheses times x minus 7 in parentheses. I just want you to pause this for a moment and think about what the answer is, or at least what you believe the answer is. And then we'll talk about what the process is for solving this. So go ahead and pause and consider the answer, and then we'll take a look at it. All right, now that we've considered what the answer is, let's talk about how we're going to do this. This is going to use distributive property, but it's going to be very important to understand how that distributive property works. Everything in the first parenthesis has to distribute to everything in the second parenthesis. So the x has to get sent in to the x and the negative 7. And then the 4 has to get sent in to the x and the negative 7 as well. And because of this, it gives us more terms than we might have considered originally. So if I follow this distribution, the first thing I'm going to get is x times x. And x times x is x squared. And then it's going to be x times negative 7. So it's going to be negative 7x. And now I have to distribute the 4. So this is going to be 4 times x, which is 4x. And then 4 times negative 7, which is negative 28. We're going to now look to have combining like terms. And usually when we do problems like this, you're going to have like terms in the middle. So the x squared stays in front. A -7 and a positive 4x is -3x. And then a -28 at the end. It's usually that middle term of the -3x that we don't consider the first time we see a problem like this. You're usually going to have like terms in the middle that combine, so always be on the lookout for those. All right, so let's look at example number 2 here. Again, we're going to distribute everything from the first parenthesis to the second one. So we're going to send that in there and there. Then we're going to send that one in there and there. So the first distribution is 3y times 2y. So 6y squared. And then I'm going to send in 3y to the 4. And that's going to be plus 12y. And then finally, we're going to send in the -8. So -8 times 2y is -16y. And -8 times 4 is -32. We're going to look for like terms. And sure enough, we have like terms in the middle again. So I'm going to have 6y squared in front. A positive 12 and a -16 is -4y. And then -32 at the end. And that would be your final answer after multiplying binomials. So you're going to take everything from the first parenthesis and distribute it into everything in the second parenthesis. And this concept can actually take place even if they're larger than 2 terms times 2 terms. If I had a trinomial times a trinomial, I would just send all 3 from the first one and multiply it to all 3 in the second one. So let's take a look at one last problem here and your example to try on your own. So go ahead and pause the video here and do this one on your own. All right, so now that we're back, let's see how you did. We're going to distribute the 5x to both. So 5x times 3x is 15x squared. And then 5x times 1 is plus 5x. Now let's send in the 7. 7 times 3x is 21x. 7 times 1 is plus 7. Look for like terms, and sure enough, they're in the middle. So I get 15x squared. Positive 5 and positive 21 is positive 26x. And then plus 7. So this is multiplying binomial times a binomial. And that's the end of the third section. These first couple parts of polynomial unit are all going to be pretty straightforward. And again, if you need to go back and rewatch this lesson before you go to your IXL section, you can. We will be building on this. These will get a little bit more difficult. And it is a very important section because what we're going to be doing next is working with a totally different style of function that's going to require us to use all of these skills. So I hope that this was helpful for you, and I'll see you guys later.